Hello, my bachcho. Welcome back. So, your exams are right around the corner. I know. And this chapter, Motion in a Straight Line, I know it can feel a little stressful. But hey, don't you worry. In this quick revision, we're going to break it all down, make it super simple. And trust me, by the end, you'll be solving those problems like a pro. So let's do this.
I see all your comments, all your messages, so much exam tension. Arey, my dear students, tension nahi lene ka. Seriously, physics is all around us, and once you see the logic behind it, it's actually a lot of fun. I promise you, just stick with me, and by the end of this, you are going to feel so much more confident.
Okay, so first things first. Before we can jump into all the formulas and problems about motion in a straight line, we have to be absolutely crystal clear on what motion itself even means. So let's start with the absolute basics, simplified just for you.
And you know what? It really is this simple. Motion is just when an object changes its position with time. That's it. Think about it. A train is at one station, and a few minutes later, it's at the next one. It's in motion. A leaf falling from a tree, in motion. The main idea here is that its location is changing as the clock ticks. Simple, right?
Now look, objects can move in all sorts of crazy ways, right? A cricket ball spinning through the air, a car taking a sharp U-turn. But for this chapter, we're keeping things simple. We're focusing only on motion in a perfectly straight line. And the fancy name for this is rectilinear motion. Just think of a sprinter running the 100-meter dash, or a car on a long, straight highway. That's what we're talking about. All right, so we know an object is moving. So what's the next obvious question? Well, how fast is it moving? And this brings us to speed, and its very important cousin, velocity. Now, they sound almost the same, but in physics, listen carefully, there's a really important difference. So, speed just tells you how fast you're going. That's it. If your dad says he's driving at 60 kilometers per hour, he's talking about the speed. But velocity is more specific. It's a vector, which means it tells you both the speed and the direction. So saying 60 kilometers per hour heading north towards Delhi, that, my friends, is velocity. Direction is the secret ingredient. Remember that. But what about the speed at one single moment? You know when you just glance at the speedometer in the car? That's your instantaneous speed. And here's a super simple trick. It's just the number part, or the magnitude, of the instantaneous velocity. So if a car's velocity is, say, negative 24 meters per second, its instantaneous speed is just 24 meters per second. Easy peasy. Okay, now for my favorite part, the real drama of motion. I mean, things don't just move at the same speed all the time, do they? No way. They speed up, they slow down. And the concept that describes this change is the mighty Mr. Acceleration.
So what is this acceleration really? It's just the rate of change of velocity. Think about a Mumbai local train leaving the station. It starts slow and goes faster and faster. Its velocity is increasing. That's positive acceleration. And what happens when it's approaching the next stop? The driver hits the brakes, its velocity decreases. That's negative acceleration, which we also sometimes call deceleration.
One of the best ways to actually see what's happening is with a velocity time graph, or a VT graph, just like this one from your textbook. I want you to think of this graph as a picture that tells the whole story of an object's motion. And the secret to understanding acceleration is hidden right there, in the slope of the line. And it's really intuitive, trust me. If the line on the graph is sloping upwards, what does that mean? It means velocity is increasing, so we have positive acceleration. Vroom! And if the line is sloping downwards, well, velocity is decreasing. The object is slowing down. That's negative acceleration. The brakes are on. And what about a flat horizontal line? Well, that means zero acceleration. The object is moving at a constant velocity.
Okay, bachcho, now I need your full attention. This is the part that will help you solve almost any numerical problem from this chapter in your exam. I call them the 3 magic formulas. These are your exam superpowers.
So get ready. Presenting the 3 kinematic equations. These are the tools that will unlock everything.
And here they are, the 3 magic equations of motion. You absolutely 100% need to memorize these. Let's go through them. First, v equals v naught plus a times t. Second, x equals v naught t plus half at squared. And the third one, v squared equals v naught squared plus 2ax. Write them down, say them out loud. These are your best friends for the exam.
Okay. Memorizing formulas is one thing, but using them, that's where the real magic happens. So let's not be scared of the numericals. We're going to take a problem straight from your NCERT book and solve it together, step by step. Chalo, let's do it.
Okay, let's tackle this question. It's a classic one, similar to example 2.3 in your book. So, picture this. You're standing on top of a 25-meter high building. You take a ball and you throw it straight up at 20 meters per second. Now what's going to happen? The ball will go up, it'll stop for a split second, and then it'll come back down, past you all the way to the ground. The big question is, how long does that whole journey take?
Now, to solve any problem like this, we're going to use our simple 4-step method. It's like a secret recipe. First, we list all the given info, everything the problem tells us. Second, we identify the unknown, what we need to find. Third, we look at our 3 magic formulas and pick the right one for the job. And finally, step 4, we just plug in the numbers and solve. Simple.
All right, let's use our method. Step 1, list the given info. Our starting position, y naught, is 25 meters, right? Our starting velocity, v naught, is positive 20 meters per second because we're throwing it up. The final position, y, is the ground, so that's 0. And what's pulling the ball down the whole time? Gravity. So our acceleration a is negative. Let's take it as 10 meters per second squared to keep the calculation simple. Step 2, the unknown is time, t. So, step 3, which formula connects all these? The second one, y equals y naught plus v naught t plus 1/2 at squared. Perfect. Now for step 4, we just plug in our numbers. 0 equals 25 plus 20t plus 1/2 negative 10 t squared. Now this looks like a standard quadratic equation, which you know how to solve.
And when you solve that quadratic equation, you get the answer t equals 5 seconds. See? It wasn't so scary, was it? When you just follow the steps, it all falls into place. This shows you just how powerful these formulas are, and you can absolutely do this in your exams.
But you know, beta, physics isn't just about exams and formulas. It's about understanding the world around you. Let me show you just 2 quick examples of how this chapter is incredibly important in our daily lives.
So look at this number on your screen, 4 times. What could this mean? It's a very, very important number, especially when we talk about road safety.
So here's what that 4x means. Remember our third magic formula, the one with the squares? It tells us that your stopping distance is related to the square of your speed. So think about it. If you're on a scooter and you double your speed, say you go from 20 to 40 kilometers per hour, your braking distance doesn't just double. No, it becomes 4 times longer. This is exactly why speed limits are so important. It's pure physics in action, keeping us safe.
And how about this one? This simple ruler drop experiment from your book is a fantastic way to measure your own reaction time. That's the tiny, tiny delay between when you see something happen and when your body can actually react to it. For most of us, it's about 0.2 seconds. Now that might sound super fast, but in that tiny fraction of a second, a moving car can travel several meters. This is precisely why texting while driving is one of the most dangerous things you can do. Physics proves that our brains have a built-in lag.
So, the main takeaway I want you to have is that this chapter, it's happening all around you, every single day. I'll leave you with one final question to think about. We learned that gravity accelerates all objects at the same rate, right? So, imagine you're on the moon, where there is no air resistance, and you drop a light feather and a heavy bowling ball at the exact same time. Which one would hit the ground first? The answer is pure physics. Think about it. All the very best for your exams, my dear students. You are going to do great. You've got this.